Hi everyone, thanks for watching this video. My name is Felipe Vargas Hernandez and I'm going to talk about the seasonal tropical cyclone forecast for the Middle Americas. To begin with, I'm going to give you the objectives for this work. The first is to determine the oceanic regions that will be active in a given season by using outputs from the global models that are available in the climate data store. This is going to be the dynamical approach of this work. The second is to obtain the statistical regressions that use historical relationship between types of tropical cyclone tracks and large-scale variables provided by the ERA 5. This is going to be the statistical approach. The last is use skill score for evaluating the ability of the statistical and dynamical models to forecast tropical cyclone density activity and the number of tropical cyclones per cluster. Here, I put you an example of the tracks of tropical cyclones during the period of time of 1851-2006 over intra-American seas and the eastern North Pacific Ocean, that is more or less the same study region as our work. As told you before, we we use two distinct approaches that are the dynamical approach and the statistical approach. I'm going to give you a brief description of this methodology. The statistical approach. This approach is based on historical relationship between types of tropical cyclone tracks and large-scale variables provided by the ERA 5. For our work, our approach provides the number of tropical cyclones for each cluster from the intra-American seas and the Eastern Pacific Ocean. The dynamical approach, this approach is based on the use of dynamical models that solve the mathematical equations that govern the physics and motion of the atmosphere. For our work, we forecast the tropical cyclone-like vortex using the model outputs. We use 5 global models available in the climate data store. Combining these two approaches, we have the statistical dynamical approach. That is a combination of the statistical and dynamical techniques, considering regression based on seasonal forecasts produced by the dynamical models. As told you before, we use the output of 5 global models, and these are highlighted with an asterisk in this table. You can see that we choose mainly these 5 model because of two parameters. The first is the resolution. We want models that have at least 1 degree of resolution, and they also were coupled to a oceanic dynamic model. We take the data from the climate data store that you know that is inside of a bigger project that is the subseasonal to seasonal project. Just to tell you a little about the S2S, this is a database that contains forecasts of several time scales from subseasonal to seasonal periods. 11 international operational centers run global models to provide a wide range of outputs. The objective is to evaluate their skill in predicting climate in different time scales. Taking into consideration what I told you before, I'm going to show you some of the results that we have obtained for each of the different approaches. First, I'm going to show you the result for the dynamical models. We are going to show, I am going to show you the tropical storm track density anomaly. Later, the verification of the dynamical models using the ERA 5 data, the Spearman correlation, and the root mean square error. For the statistical models, later I'm going to show you the regression models for tropical cyclone from the intra-American seas and the Eastern North Pacific, and the verification of the statistical models using the HURDAT database, the Spearman correlation and the row curve, and the area under the row curve. Well, for the dynamical models, we compute the tropical storm track density. This was computed for two initial conditions. The first initial condition is for the 1st of June and to cover the months of June, July, and August. The second initial condition is for the 1st of August, and this is used to cover the months of August, September, and October. As you can see here for the first initial condition, we have the model output for the 5 global models. We have the multimodal ensemble, the observation that were taken from the HERDA database. As you can see here, some models are overestimating the activity of the tropical storm track density anomaly in the North Atlantic, for example, the SMWF, the UK Met Office, and the CMCC compared with the observations. Another thing that you can see is that most of the models are underestimating the activity of this tropical storm track density anomaly in the Pacific Basin, as you can see also compared with the observations. For the second initial condition, you can see an increase in the density track in the Atlantic basin compared with the first initial condition, and the models are simulating well this behavior, but again they are overestimating this activity in the North Atlantic basin. As you can see also, the models are underestimating this activity in the Pacific basin for this initial condition. Well, for verification, we compute the Spearman correlation, as told you before, of the tropical cyclone density anomaly. You can see here for the first initial condition that most of the models in the region of the Atlantic Ocean have good correlation with the observations, as you can see here for most of the models. For the Pacific Basin, you can see that there is a region of negative correlations um, that could mean that the models have like problems to simulate the tropical cyclone density in this region, as we saw with the previous results. For the second initial condition, we can see that the region with positive values of the correlation are higher than in the first initial condition. You can see also that the region with negative values of the correlation in the Pacific Basin is shorter in this second initial condition. This means that for the second initial condition we have a better correlation between the observed values and the predicted ones. To see why the models are overestimating and underestimating the activity of the tropical storm track density in both basins, we download data from the ERA 5 of variables that are precursors of the formation of tropical cyclones. So we evaluate the data download from the ERA 5 of surface temperature, the geopotential height, the specific humidity, the U&B component to compute the vertical wind shear, and as you can see here in this image, we compute the Spearman correlation of the vertical wind shear. This also for the two initial conditions. As you can see here in this image, uh, the models have, as most of the models have a region of negative correlation in the Pacific Basin, where the models are underestimating the activity of the tropical storm track density, as you can see here for most of the models. Also, we have a region of negative correlation near the coast of Africa, and although we have positive values of the correlation between the observed and the predicted values for the North Atlantic, these are very low, like between 0 and 0.4. For the second initial condition, you can see also this region of negative values of the correlation in the Pacific Basin, and you can see also that the region of negative correlation near the coast of Africa has extended in the longitude, and we can expect, or we are suspecting that the variable that could be affecting the behavior of the tropical storm track density anomaly could be the vertical wind shear, because these use the U and B component of wind to be calculated, and also the track technique that we use uses this variable to get the tracks. Another verification metric that we compute for the dynamical models is the root mean square error of the tropical storm track density. As you can see here, for the first initial condition, for the Pacific Basin, we have high values of the root mean square error. You have to remember that the lower the root mean square error is better. So you can see this. You can see here this region of high values of the root mean square error for the Pacific Basin, where the models are underestimating the activity of the tropical storm track density. For the Atlantic is distinct. You can see that the values of the root mean square error are very low for the first initial condition. For the second, you can see also this region of high values of the root mean square error, and that the root mean square error increases in the North Atlantic, as we can see with the second initial condition of the track density, that the models again are overestimating the activity in this region of the North Atlantic. We also compute the root mean square error of the vertical wind shear for the two initial conditions, and you can see that we found largest bias in the northwards of 15 degrees, more or less greater than 20 meters per second. And interestingly, this score showed that the vertical wind shear over the Caribbean region, Gulf of Mexico, and near the west coast of Mexico are poorly simulated. So again, as told you before, you can see that the vertical wind shear could be the variable that is affecting the behavior of the tropical storm track density. Well, for the statistical models, as told you before, we provide the number of tropical cyclones per cluster. So, as you can see here in this image that was taken from Dominguez and Magaña, they cluster the different kind of trajectories by its kind. So you can see that they have 4 clusters for the intra-American seas, and later you are going to see that they have also 4 clusters for the Eastern of Pacific. So we have to remember that the tropical cyclones contribute up to 30% of the seasonal precipitation, mainly over northeastern of Mexico, and this is why it's important to compute the number of tropical cyclones in these regions. Well, as told you before, we compute the statistical model for each of the clusters that I showed you in the previous image, and as you can see here, we have the statistical models for the cluster A and the cluster B. You can see the equation for each of the models. You can see the predicted values in the red line, the observed values in the blue line, and in the shading you have the confidence intervals at the 95 percentage level. Something important of this statistical model that you are going to see in the next ones also is that some variables are repeated in the equation of the models, and these variables are the ones that are reported in the literature to be the precursors of the tropical cyclones. For example, the surface temperature and the vertical wind shear. But we also use some oscillations like the Oceanic Niño Index. Again, you can see here the Pearson and the Spearman correlation for the predicted and observed values. You can see also the models for the cluster C and the cluster D with their equation and the Pearson and the Spearman correlation. For the verification of the statistical models, we compute the RO curve of the models. You have to remember that to understand the RO curve must be above this blue line, that is the line of non-skill, because if the model falls below of this line of non-skill, well, the model doesn't have ability to discern between the currents and non-currents of an event. In this case, the event is that the season is going to be above the median or below the median. So as you can see here, most of the models have ability because they are above the line of non-skill. And also another metric that you can use to verify this is to compute the area under the RO curve that you can see here, and this value must be greater than 0.5 to say that the model have ability. As you can see, most of the models have the value greater than 0.5 for these three clusters. We can compute the ROQ for the cluster B for these intra-American seas. For the statistical models, again, we have here the cluster over the Eastern Pacific as with the intra-American seas. For this, we also compute the statistical models for each of the clusters. You can see also the equation, the predicted value in the red line, and the observed value in the blue line, and the confidence intervals at 90% level. We also have the Pearson and the Spearman correlation for each of these models. Something important of these models in difference with the one from the intra-American seas is that this doesn't have like the same precursor variables to predict the number of tropical cyclones. In fact, here for the Eastern Pacific, we don't have like repeated variables as with the American seas. Another important thing that you can see with the clusters is that they have a shorter value of the Pearson correlation compared with the intra-American seas. For this, we also compute the RO curve. You can see here for the cluster A that rock curve, some of the values of the rock curve fall below the line of known ability and some of them above the line of known ability. In fact, if you can see the area under the rock curve, it has 0.55 that is just above the value of known ability. So this model uh, could have some trouble to forecast the occurrence or not occurrence of this event. For cluster B, you can see that we have the rock curve above the line of notability, and also for the cluster C and the cluster D. In fact, you can see that the cluster D is the one that has the best area under the rock curve. Well, so for future work for this work, we want to forecast the number of tropical cyclones per cluster in both basins using the seasonal forecast of large-scale variables from the dynamical models, because the models that I showed you before, the statistical models, were not computed with the values of the dynamical models, were computed with the values of the ERA 5 data because of the time. And the last of the future work, we want to use skill scores to measure the ability of this statistical dynamical approach. So I hope that you have enjoyed this presentation, and if you have any question, you can contact us with here is our email. So thanks again.